Hello guys, welcome to another video. In this video you will learn the basic concepts and principles of obstacle avoidance in a simple two-wheel balanced robot. As I have introduced earlier, the robotic module is very simple. It includes an AVR development board containing 8 MHz microcontroller, a motor driver IC for driving the motors which are connected to the wheels, and also an IC which is on top right corner, the decoder IC which will not be using in this particular experiment. The two infrared sensors mounted at the front of either of the wheels of the robot form the important component in this particular experiment, which is the obstacle avoidance. These sensors are used to recognize the object which come in front or side of the body of the object. So output from the infrared, the digital output of the infrared sensors are connected to the input in either one of the port of the microcontroller. So the program loaded, which we have loaded in the microcontroller, senses the input and acts accordingly, producing the output, and drives the motor accordingly based on the sensor inputs. So mainly this particular program which I have written consists of two sections, and the first one is the action of the robot if an obstacle comes, or if an obstacle is encountered to any one of the sides of the robot, either to the left or to the right. And the second section deals with the obstacle which are encountered straight in front of the objects, so that straight in front of the robot, so that the robot cannot move any further and it needs to reverse its direction and take a new direction to continue its path. So in the former section, the working is very simple. As I have already introduced about the sensor, when an obstacle is encountered at any of the sides of the object, as infrared sensors which are on the corresponding sides has output 1. Let me tell you how it is. The infrared sensor consists of IR LED and a photodiode. The IR LED continuously reflects IR radiations, but if there is no obstacle in front of the object, the radiations travel straight and are not reflected back to the photodiode. But when a particular obstacle is encountered in front of the robot, the sensors, the IR radiations reflect back from the particular obstacle and are successfully received by the photodiode. So I have programmed it in such a way that when the obstacle is encountered, the sensor output which are 1 are fed into any of the port pins of the microcontroller. So assume an obstacle to be encountered on the left of the chassis. The left sensor output will be 1, and according to the program which have been loaded in the microcontroller, the wheel which is on the left continues its rotation, and the wheel which is opposite to the obstacle position stops suddenly, so that the whole robot module turns to right direction, so that the obstacle which is on the left is avoided and the robot continues its direction as soon as it avoids the obstacle. So the second situation is one obstacle comes right in front of the robotic module. Both the sensor outputs are 1. So I have programmed it so that the robot suddenly stops so as not to collide with the obstacle, and it suddenly reverses its direction by reversing the direction of rotation of both the wheels for about uh, 2 or 3 seconds, which can be manually written in the program by delay section uh, delay section. So I think I have given a delay of 3000 milliseconds, which is nothing but 3 seconds. So the robot continues to reverse straight backwards for about 3 seconds and stops there, and then I have written the program so that any one of the wheel of the robot rotates for about 800 milliseconds or zero point 0.8 seconds, and the robot turns in certain angle so that it avoids the obstacle, and then it continues its path by rotating both the wheels in forward direction until another obstacle is detected. So this forms the basic principles of obstacle avoidance in a simple robot. I wish you to use this principle to form your own robot and enjoy your experience. And thanks for watching the video. See you next time.